Hello everyone, dear friends. Today we have a wonderful chapter of inorganic chemistry, coordination compounds. According to NCERT, weightage of this chapter is 6 mark, with question 2 is question number 25 and question number 26. You keep yourself, friends. Already the question number 26 is almost known. There is an VP. It's a Pakka 3 marks question. Is explain valence bond theory of the corresponding 4 complex, 2 cobalt and 2 nickel for your academic syllabus. And question number 25 is also having a weightage of 3 marks. Here we have various types of concepts, friends, types of complex, types of ligands, and nomenclature of coordination compounds. A very important and 2 mark question is isomer and isomeric characters of coordination compounds. Yes, so this is a brief concept of exam point of view for a weightage of 6 mark. How to earn this 6 mark from this chapter. Different coordination compounds. Before to start the coordination complex or coordination compounds, let us start with a simple chemistry. Is simple salts. I think all of you know what are simple salts. These are the salts which containing one cation and one anion. There one salt now the cation and anion simple salt like example sodium chloride, potassium chloride, aluminium sulfate, A2SO4 thrice. There are so many examples we know in PUC first year level in our laboratory. And after this simple, we come to the next one is double salt. So what are double salts? Very simple definition is a component KCl MgCl2 6H2O. I think all of you know the name of this compound is carnallite. This is your example of double salt. How can you define double salt? The double salt is contribution of 2 simple salts or either 2 cations and 2 anions. The contribution of 2 cations and 2 anions or either a combination of 2 simple salts are known as a double salt. This example according to our syllabus is a carnallite. If you want to know the potash, alum is also another double salt with a chemical formula K2SO4 Al2SO4 thrice 24H2O. This is the chemical composition of potash alum, commonly we call it an alum also. I repeat, and before the coordination compounds, we have a simple salt which having 1 cation and an anion, and double salt which is having a 2 cation and 2 anion or either a combination of 2 simple salts like example KCl MgCl2 with binding with water of 6 molecule, and potassium sulfate and aluminium sulfate is binding with 24 water molecules. The name is carnallite and this is your component is potash alum. This is a simple story behind the coordination compounds. You know, friends, the simple as well as double salt. And after this simple and double salt, let us move on to the next bit of our syllabus. What are complex salts? So, what are complex salts? Before to know the definition, friends, we have an example. And the example yes, this is the best example of a complex salts. Your complex salt is one example. If you want to know another one, K4 FeCl6. A complex salt or coordination complex is nothing but a central metal atom. The central metal atom or ion. The central metal atom or ion surrounded by electron donor atoms. Electron donor atoms called ligands. The central metal atom or ions are surrounded by electron donor atoms are called complex salt or coordination complex. ಅಂದ್ರೆ ಏನು ಮಕ್ಕಳೇ, ಒಂದು coordination complex ಅಥವಾ complex salt ಆಗಬೇಕಾದ್ರೆ ಎಸ್ ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಇರಬೇಕು ನನಗೆ. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್. Central metal either atom or either ionic form. Yes, this is your electron donor atom. This ammonia is electron donor atom. This is, we call it is an ligand. What are complex? The central metal atom or ion surrounded by the electron donor atoms, they are called ligands. Andre electron ಗಳನ್ನು ಕೊಡುವಂತಹವುಗಳಿಗೆ ನಾವು ಏನಂತ ಕರೀತೇವೆ? Ligands. Pronouns ligand, not legend. It is a ligands. Yes, they are surrounded by with ligands are known as complex salt. Complex salt ಆಗಬೇಕಾದ್ರೆ electron donor ಇರಬೇಕು, ಅದನ್ನ ligand ಅಂತೀರಾ. Commonly we call it is an Lewis base. The Lewis base are the electron donors. However, electron ಯಾರಿಗೆ ಕೊಡ್ತದೆ? Central metal ಗೆ ಕೊಡ್ತದೆ. Means central metal is electron acceptor. Central electron electron ಅನ್ನು ಪಡೆದುಕೊಳ್ಳುತ್ತದೆ, ligand ಗಳು electron ಅನ್ನು ದೊರೆಯುತ್ತದೆ. So central metal ಯಾವುದು ನೋಡ್ಕೊಳ್ಳಿ. Copper is a transition metal, 3D series, 3D element. ನಾನು ಹೇಳಿದೆ ನಿಮಗೆ, yes, transition metals are create a good complex. Why? Because they are very small in size. Size ಅಲ್ಲಿ ಸಣ್ಣದಿದೆ, first point. Second one, vacant d orbital. D orbital vacancy ಇದೆ, ಹಾಗಾಗಿ electron ಗಳನ್ನು ಈಸಿ ಆಗಿ ತಗೋಬಹುದು ಸರ್. Vacant d orbital. So these are the reason the formation of the complex. ಹಾಗೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗಲಿಕ್ಕೆ ಕಾರಣ as transition metal or central metal must be small in size and vacant d orbital can easy to create a complex. ಹಾಗೆ ಹೇಳ್ಬಿಡೋಣ, what are complex salt ಮಕ್ಕಳೇ? The central metal atom or ion surrounded by the electron donor atoms to form a compound is known as complex salt. Like example, CuNH3 4 times, K4FeCN6. If you want K3FeCN6. These are the complex which are here. Iron is a central metal. A cyanide is an ligand. Iron is a central metal. A cyanide is a ligand. ಹಾಗಾದ್ರೆ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗಬೇಕಾದ್ರೆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಇರಬೇಕು ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಕೊಡುವಂತಹ ಲಿವಿಸ್ ಬೇಸ್ಗಳು ಇರಬೇಕು. ಅದು ನಿಮ್ಮ ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಾಲ್ಟ್ಗಳಾಗಲಿಕ್ಕೆ ಅತಿ ಮುಖ್ಯ. Now friends, you keep yourself ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಾಲ್ಟ್. ಸಿಂಪಲ್ ಸಾಲ್ಟ್ ಆಯಿತು, ಡಬಲ್ ಸಾಲ್ಟ್ ಆಯಿತು, ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಾಲ್ಟ್ ಆಯಿತು. ಹಾಗಾದ್ರೆ ಈಗ ನಮಗೆ ಗೊತ್ತಾಗಲಿ, ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗಲಿಕ್ಕೆ we need the two concepts. ಇಬ್ರು ಬೇಕು ಸರ್. ಯಾರ್ಯಾರು ಬೇಕು? ಎಸ್, ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್, another one is a ligand. What are central metal? These are electron acceptor. Electron acceptor best is a 3D series. Yes, now 3D series, scandium to the zinc. These elements comes under the central metals. Now our target is very important, ligands. Ligands ಏನು? Ligands are atoms, group of atoms. Ligands are atoms, a group of atoms or molecules. Atoms or group of atoms or a molecule which donate. Very important. Which donate. Donate means Lewis base. Which donate pair ಅನ್ನೋದು ಜೊತೆ pair of electrons to the central metal atom or ion. ಅದರ ಲಿಗ್ಯಾಂಡ್ಗಳು ಅಂದ್ರೆ ಏನು ಅಂತೀರಾ ಇವತ್ತಿಂದ? ಲಿಗ್ಯಾಂಡ್ಸ್ ಗ್ರೂಪ್ ಅಟಮ್ಗಳಿರಬಹುದು, ಗ್ರೂಪ್ ಆಫ್ ಅಟಮ್ಸ್ ಇರಬಹುದು ಅಥವಾ ಮೊಲಿಕ್ಯೂಲ್ಗಳಿರಬಹುದು. ಅದರ ಕೆಲಸ ಏನು? ಡೊನೇಟ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಡೊನೇಟ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. ಯಾರಿಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡ್ತದೆ? ಡೊನೇಟ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಸ್. ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಸ್ ಅಟಮ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರಬಹುದು, ಅಯಾನಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದ್ರು, ಇದನ್ನು ನಾವು ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಹಾಗಾದ್ರೆ ನೆನ್ಪಿಟ್ಬಿಡೋಣ, ವಾಟ್ ಆರ್ ಲಿಗ್ಯಾಂಡ್ಸ್? Ligands are atoms, group of atoms or a molecule which having the capacity to donate at least a pair, ಒಂದು ಜೊತೆ ಕೊಡಾಕಬೇಕು, at least a pair of electrons to the central metal atom or ion are known as ligands. ಇದಕ್ಕೆ ನಾವು ligandಗಳು ಅಂತ ಕರೀತೀವಿ. This is the very important part of our syllabus, ligand and ligand character. Now, yes, after this definition, friends, we come back to the classification of ligands. Ligandಗಳನ್ನು classify ಹೇಗೆ ಮಾಡ್ತಾರೆ? But there are two types of classification will be takes place. The number one, based on charge. Second one is very important, based on donor sites. ಏನಂತೀರಾ? Ligands are classified on based on two characters. One is based on charge and another one is based on donor site, a pair of electron. It's based on charge. I think all of you know, positive, negative, or either a neutral. But a positive we call as a cationic ligand. Cationic ligand or positive ligands. We call as a negative ligand. Dot ಬರ್ದಿದ್ದೀರಲ್ಲ, call it is a neutral ligands. ಲಿಗ್ಯಾಂಡ್ಗಳಲ್ಲಿ ಮೂರು ರೀತಿ, ಪಾಸಿಟಿವ್ ಚಿಹ್ನೆ ಇದ್ರೆ ಅದನ್ನು ಕ್ಯಾಟಯಾನ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೀತೇವೆ, ನೆಗೆಟಿವ್ ಇದ್ರೆ ನೆಗೆಟಿವ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೀತೇವೆ, ಅಥವಾ ಡಾಟ್ ಬರ್ದಿದ್ರೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ನ್ಯೂಟ್ರಲ್ ಲಿಗ್ಯಾಂಡ್. ಹಾಗಾದ್ರೆ based on the charge, ligands can be classified into three types. One is positive and negative and neutral ligands. And based on the donor sites is how much they have ready to donate a pair of electron. If they donate a single or one pair, ಒಂದು ಜೊತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡ್ತಾ ಇತ್ತು ಅಂದ್ರೆ we call it a monodentate, not a dental, it's a monodentate ligand. Two pairs we call it a bidentate or didentate. Bidentate ligand or either a bidentate. More than three, commonly called as a tridentate, tetradentate, polydentate. This more than three we call is a polydentate. I repeat, friends, based on donor sites, the ligands are classified either they donate one pair, ಒಂದು ಜೊತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟರೆ ಮಕ್ಕಳೇ monodentate ಅಂತ ಕರೆಯೋಣ ನಾವು, ಎರಡು ಜೊತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟರೆ ಬೈ ಅಥವಾ ಡೈಡೆಂಟೇಟ್ ಅಂತ ಕರೆಯೋಣ, ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಂದ್ರೆ 3, 4, 5 ಪೇರ್ಗಳನ್ನು ಕೊಡ್ತಾ ಹೋದ್ರೆ we use the word is a polydentate ligand. This is the major concept of the chapter is a coordination compounds. Today in this video, friends, we have an introductory part of simple salt, double salt, complex salts, complex ligands and types of ligands. These ligands are classified in two patterns, based on charge and based on donor site. In the next video, we carry the concept of the charge base as well as donor base. Thank you so much. Welcome to everyone. Dear friends, in the last video we have a concept of types of ligands. Dear friends, ligands are two types. One is based on charge. This based on charge, the ligands are classified into three types. One is positive type of ligand, commonly we call is a cationic ligands. And what are the cationic or positive type of ligand? The charge of ligand is positive. So an example of this one is very important, is NO2 plus. I think all of you know this is known as nitronium. Nitronium ion is NO2 plus. Yes, if you want to know, this is an NO plus. Is a nitrosonium, Nitrosonium. Nitronium or nitrosonium, these are the best examples of cationic ligand or either a positive type of ligand. I repeat, friends, what are positive type of ligand? These are the ligand which having positive charge. Keep yourself, they are electron deficient. Positive charge means electron deficients themselves. But the second category is negative type of ligands. I think of the generic definition. These are the ligands, the charge of ligand is a negative. These are the ligands which donate at least a pair of electrons to the central metal, but they are having a negative charge like cyanide Cl minus, or either halogen, it is an X minus, becomes Cl minus, Br, F and I. Chloride ion, bromide, fluoride and iodide, halogens are also the negative charge. If you want to know, this is an oxalate, C2O4 minus 2 oxalate ions. They are negative type of ligands. So many negative type of ligands we come across: cyanides, halogens, oxalate ions. It's a negative type, friends. And the third one is very important, is a neutral type of ligand. What are neutral type of ligand? These are the ligand which does not having any charge, as do not having any charge, but they have lone pair of electrons. At least a lone pair of electron, they have to donate to the central metal. Have a neutral ligand charge iralla makkale, but adರಲ್ಲಿ at least lone pair of electron irutte. Like example, ammonia is a neutral ligand, water is a neutral ligand, yes, carbonyl is a neutral ligand. So many neutral ligand. If you want to know another best example of our syllabus, this is your compound ethylene diamine. This is the best example of neutral ligand. I repeat, based on the charge, ligands are in three categories. One is a cationic ligand, means they are positive charge. Negative ligands which having negative charge. Neutral ligands which does not having any positive and negative charges, but they do not having any charge, but they have lone pair of electron which has to donate the electrons to the central metal. These are the type 1. One other question, give an example of a negative ligand, give an example of neutral ligand. ನೆನಪಿಟ್ಕೋರಿ, ಲಿಗ್ಯಾಂಡ್ಗಳಲ್ಲಿ ಮೊದಲನೇ ಕ್ಯಾರೆಕ್ಟರಲ್ಲಿ 3 ನಾನು ಹೇಳಿದ್ದೇನೆ: ಪಾಸಿಟಿವ್, ನೆಗೆಟಿವ್ and neutral. And after this positive and negative neutral, we come to the next one, is based on very important donor site, which is mentioned exactly in our NCERT syllabus. Yes, I repeat once again along with this, what are ligands? Ligands which donate at least a pair of electrons to the central metal. ಅಂದ್ರೆ ಲಿಗ್ಯಾಂಡ್ ಕೆಲಸ ಏನು? ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನ ಕೊಡೋದು. ಯಾರಿಗೆ? ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನ ಕೊಡೋ ಕೆಲಸ ಮಾಡ್ತದೆ. ಅದಕ್ಕೆ ನಾವು ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೀತೇವೆ ಮಕ್ಕಳೇ. ಅದರಲ್ಲಿ ಈಗ ನಾವು based on donor sites, they are classified. The first one is monodentate. Now ಹೇಳಿದೀನಿ. What are monodentate ligands? These are the ligands. Monodentate ligands are the ligands which donate one, very important, one pair of electrons. These are the ligands which donate one pair of electrons to the central metal, are known as monodentate ligand. This, what are those? For example, cyanides, all halogens. If you want to water, if you want to know ammonia, these are the monodentate ligands. The monodentate ligands are the ligands which donate only one pair of electrons to the central metal. We have so many examples. I will give the list, friends, after this ligand classification. Cyanide, halogens, water, ammonia, they comes under monodentate. And now come to the second one, is bidentate. Bi or another term is didentate. These are the ligands which donate two pairs of electrons. They donate two pairs of electrons to the central metal, are known as bidentate. Keep yourself, this is very, very important for 1 mark. Yes, give example: oxalate. what is oxalate ion? The formula is C2O4 minus 2. Keep yourself so many times the write the structure of oxalate ion. The 2 carbon atoms. This is the 2 carbon atoms. Yes, these are the 4 oxygen atoms. Oxygen valency, divalency, friends. Carbon is tetracarbon is tetra. This is the negative charges. C2O4 minus 2. This is the symbolic notation of your oxalate. Yes, abbreviation of this oxalate they pronounce as OX. Don't pronounce ox, it is OX. And another one, ethylene diamine. Ethylene diamine. Yes, symbolic notation is En. The formula is CH2. CH2. This is your NH2. NH2. Nitrogen having a lone pair here. This is your. Yes, this is your. So bidentate ligands are the ligand which having the capacity to donate 2 pairs of electrons to the central metal are known as bidentate. The 2 interesting examples, oxalate ion formula C2O4 minus 2 and ethylene diamine is this. So you confusion ಮಾಡ್ಕೋಬೇಡಿ. ಫಾರ್ಮುಲಾ ಕೇಳಿದ್ರೆ ಫಾರ್ಮುಲಾ ಬರೀರಿ, ಸ್ಟ್ರಕ್ಚರ್ ಕೇಳಿದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಬರೆಯಕ್ಕೆ ಬರಲಿ ಮಕ್ಕಳೇ. Bidentate is very important. After this mono and bidentate, just to keep yourself is an polydentate ligands. Sir, what are polydentate ligands? These are the ligands which having capacity to donate more than 2 donor sites. ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಡೋನಾರ್ ಸೈಟ್ಗಳನ್ನು ಹೊಂದಿದ್ದರೆ ಅದನ್ನು ನಾವೇನಂತ ಕರೀತೇವೆ? ಪಾಲಿಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೀತೇವೆ ಮಕ್ಕಳೇ. So many examples are there. DMG, EDTA. DMG means dimethyl glyoxime. Dimethyl glyoxime is one example. And another one, ethylene diamine tetraacetate ion. Yes, very important. Ethylene diamine tetraacetate ion. This is the your polydentate ligands. So keep yourself as monodentate, bidentate and polydentate. This is the simple classification in today's class, friends, based on donor site as well as based on your charge. Keep practicing with the examples, and in the next video I will give the complete chart of mono, bi and polydentate ligands. Thank you so much. Welcome to everyone. Dear friends, today we move on to the next bit of the chapter is coordination compounds. Now we have a concept is a coordination entity. So what is the meaning of a coordination entity? Is nothing but the central atom or ion. The central atom or ion joined a fixed number of negative or neutral atom. I repeat, a coordination entity is nothing but the central atom or ion is joined fixed number of ligands, nothing but fixed number of negative or neutral atoms through coordination bond called coordination entity. I repeat, the central atom or ion joined fixed number of negative or neutral atom through the coordinate bond. Remember sir, very simple makle. Yes, this is your compound is CuNH3 4 times this is a plus 2. And this complex, I think all of you know, this is a central metal, this is your ligand, this ligand is a neutral. A central metal atom or ion is joined a fixed number of negative or neutral atoms, that is called ligands, through a coordination bond is known as coordination entity. The coordination entity of this complex is 4, means the copper which is surrounded by 4 coordinated bond with ammonia. Yes, this is a fixed entity. They cannot be changed anywhere. Yes, NH3. Yes, this is a coordination entity. A central metal which is surrounded by a fixed number of ligands are known as coordination entity. If you want to know, this is cobalt NH3 6 times. This is a +3. The cobalt is combined with 6 ammonia. This is 6 ammonias. These are the coordinate bonds. 6 ammonia ligands surrounded by the cobalt atom. Now this is your +3. This is the cobalt, your coordination entity. Coordination entity ಅಂದ್ರೆ ಏನು? The central metal ಅದಕ್ಕೆ ಫಿಕ್ಸ್ ನಂಬರ್ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನ ಅಥವಾ ಲಿಗ್ಯಾಂಡ್ ಇದರ ನೆಗೆಟಿವ್ ಆರ್ ನ್ಯೂಟ್ರಲ್ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿರುತ್ತದೆ. ಸರ್, ದಿಸ್ ಈಸ್ ಅನ್ ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್. ದಿಸ್ ಈಸ್ ಯುವರ್ octahedral. If you want to know the nickel, NiCO4 times. This is the tetracarbonyl nickel. The nickel is surrounded by a tetrahedral carbonyl. Yes, with coordination number. So this is a very simple coordination entity in our syllabus. ನೆನಪಿಡ್ತೀರಾ? coordination entity ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಫಿಕ್ಸ್ ನಂಬರ್ ಆದಂತಹ ಲಿಗ್ಯಾಂಡ್ಗಳಿಂದ ಸುತ್ತುವರಿಯುತ್ತದೆ. ಅದರ ಫಿಕ್ಸ್ ಎಂಟಿಟಿ ಅಂತ ಅಥವಾ ಫಿಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ ಕರೀತೇವೆ. ಅದನ್ನೇ ಕೋಆರ್ಡಿನೇಷನ್ ಎಂಟಿಟಿ ಅಂತ ಕರೀತಾರೆ. ಎಸ್, ಬೇಸ್ಡ್ ಆನ್ ಕೋಆರ್ಡಿನೇಷನ್ ಎಂಟಿಟಿ ಇದು ನಮಗೆ ಅರ್ಥ ಆಯ್ತು ಅಂದ್ರೆ ಮುಂದೆ ಹೋಗೋಣ. ಎಸ್, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ಈಸ್ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್. ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್? ಎಸ್, ವೆರಿ ಸಿಂಪಲ್. ಎಸ್, ಹಾಗಾದ್ರೆ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಅಂದ್ರೆ ಏನು? ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ligands ಅಥವಾ the total number of coordinate bonds. The total number of coordinate bonds, very important. The total number of coordination bonds between central metals and ligands. Central metal ಮತ್ತು ಲಿಗ್ಯಾಂಡ್ಗಳ ನಡುವೆ ಇರುವಂತಹ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕೋಆರ್ಡಿನೇಷನ್ ಬಾಂಡ್ಗಳನ್ನ ನಾವೇನಂತ ಕರೀತೇವೆ? coordination number ಎಂದು ಕರೆಯುತ್ತೇವೆ. ನೋಡಿ, yes, in this complex they have 4 coordination number. Cn ಅಂದ್ರೆ coordination number ಇಲ್ಲಿ 4 ಆಗುತ್ತೆ. ಸರ್, ಇಲ್ಲಿ R ಇದೆ, coordination number is becomes to 6. ಇಲ್ಲಿ 4 ಇದೆ ಸರ್. This is a tetrahedral geometry. The coordination number is 4. Now what is the coordination number? The total number of coordination bond between central metal and ligands are known as a coordination number. coordination number ಅಂದ್ರೆ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಲಿಗ್ಯಾಂಡ್ಗಳು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ನೊಂದಿಗೆ ಕೋಆರ್ಡಿನೇಟ್ ಬಾಂಡ್ ನಲ್ಲಿ ಇರುತ್ತದೆಯೋ ಅದನ್ನು ನಾವೇನಂತ ಕರೀತೇವೆ? ಅದರ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್. ಸಿಂಬಾಲ್ ಅದನ್ನು Cn ಅಂತ ಕರೀತಾರೆ ಮಕ್ಕಳೇ. ದಿಸ್ ಕ್ಯುಪ್ರಮೋನಿಯಂ ಅಲ್ಲಿ 4 ಕೋಬಾಲ್ಟ್ ಕಾಂಪ್ಲೆಕ್ಸ್ 6 ಇದೆ. ನೀವು 6 ಆಗ್ತದೆ. ನೀವು ಟ್ರೈ ಮಾಡಿ ಇದನ್ನು ಹೇಳ್ಬೋದು. K4 FeCN6. Sir, this is a monodentate. Coordination number is becomes once again 6. Bidentate oxalate ಬಂದಾಗ ಅಲ್ಲಿ ಕೋಆರ್ಡಿನೇಷನ್ ಬಾಂಡ್ಗಳು ಎರಡೆರಡು ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ. ಅದನ್ನು ಡಬಲ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ಬೇಕು ನಾವು. ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅಂದ್ರೆ ಟೋಟಲ್ ನಂಬರ್ ಏನು ಬೈಡೆಂಟೇಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಬೈ 2 ಮಾಡಿದ್ರೆ ನನಗೆ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಸಿಗ್ತದೆ. ಆಕ್ಸಿಲೇಟ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಇಸ್ C2O4 ಈ ತರ ಕೊಟ್ಟು 3 ಥ್ರೈಸ್ ಕೊಟ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ದೇ ಬಿಕಮ್ಸ್ ಬಿ 6. ಅದನ್ನ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಅಂದ್ರೆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ coordinate bond between ligands and central metals are known as a coordination number. It's very simple with different examples in your book. So after this coordination number, yes, let us move on to the next concept, friends, and coordination sphere and Ionic Sphere. This is a major part of our syllabus. Our syllabus is a mukya category adu coordination sphere. Yes. Sir, what is the meaning of coordination sphere? Coordination sphere anta yavudಕ್ಕೆ ಕರೀತೇವೆ ನಾವು? Yes, let's we have an example of our syllabus. Cu NH3 4 times SO. This is the best example of Cubramonium Sulfate. So here, friends, you keep yourself. This is a central metal. This is your ligand. This is your ion. And apart from the coordination sphere. Here, what is a coordination sphere? Coordination sphere is nothing but as the central metal is surrounded by the ligand or ligand which donate the electrons to the central metal. ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಏನಿರ್ತದೆ ಆ ಟೋಟಲ್ ಟರ್ಮ್ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಇರುವಂತ ಟರ್ಮ್ ಅನ್ನ ನಾವು ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪಿಯರ್ ಅಂತ ಕರೀತೇವೆ. What is the coordination sphere? Which contribute or which involving an electron donor ligands and electron acceptor central metal, which is written in a square bracket. And the square bracket ಅಲ್ಲಿ ಇದ್ದದಕ್ಕೆ coordination sphere ಅಂತ. Apart from the coordination sphere and the square bracket ಅನ್ನು ಬಿಟ್ಟು ಇದ್ದದ್ದು ionic sphere ಆಗ್ತದೆ. Yes, ionic sphere ಆಗ್ತದೆ. Keep yourself. First square bracket ಬಂದು ಆಮೇಲೆ ionic sphere ಇದ್ದರೆ ಅದಕ್ಕೆ anionic sphere ಎಂದು ಕರೆಯುತ್ತಾರೆ. Ionic sphere nothing but apart from the square bracket or apart from the coordination sphere is known as ionic sphere. After the coordination sphere we mentioned ionic sphere, there must be always anionic sphere because it is on a negative charge. ಅಕಸ್ಮಾತ್ ಈ ತರ K4 FeCN6 ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ. ಇಲ್ಲಿ ನೋಡಿದ್ರೆ this square bracket is coordination sphere. Before the coordination sphere is the ionic canal. This is ionic sphere. ಹೌದಾ? ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಗಿಂತ ಮುಂಚೆ ಏನಾದರೂ ಇದ್ದರೆ ಅದನ್ನು ನಾವು ಕ್ಯಾಟಯಾನಿಕ್ ಸ್ಪಿಯರ್ ಎಂದು ಕರೆಯುತ್ತೇವೆ. Ionic spheres are two types, anionic sphere and cationic sphere. Anionic sphere ಎಲ್ಲಿರುತ್ತದೆ ಅಂತಂದ್ರೆ coordination sphere ಆದಮೇಲೆ ಇರುತ್ತದೆ. ಕ್ಯಾಟಯಾನಿಕ್ ಸ್ಪಿಯರ್ ಎಲ್ಲಿರುತ್ತದೆ ಅಂದ್ರೆ coordination sphere ಗಿಂತ ಮೊದಲು ಇರುತ್ತದೆ. ಸೊ ಇದನ್ನ ಎಲ್ಲರೂ ನೆನಪಿಟ್ಕೊಳ್ಳೋಕೆ ಪ್ರಯತ್ನ ಮಾಡಿ. ಕಾಂಪ್ಲೆಕ್ಸ್ ನೋಡಿದ ತಕ್ಷಣ ದಿಸ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇನ್ವಾಲ್ವ್ಡ್ coordination sphere and ionic sphere. Yes, let us consider an example. ನಾನು ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತೇನೆ. NiCO. This is a 4 times tetracarbonyl nickel. ಮಕ್ಕಳು ನೆನಪಿಡಬೇಡಿ, this complex having only ionic sphere, sorry, coordination sphere. Only ಚೌಕನ್ ಬ್ರಾಕೆಟ್ ಇದೆ, ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಇದೆ. ಹಾಗಾಗಿ ಇದು ಓನ್ಲಿ coordination sphere. There is no ionic sphere. ಯಾವುದು ionic spheres ಇಲ್ಲ. ಸರ್ ಇಲ್ಲ, ನಾನು ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಬರೀತೇನೆ. K3FeCN6 ನೋಡಿಪ್ಪ. ಸೊ ದಿಸ್ ಈಸ್ ಯುವರ್ coordination sphere. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಇರೋದ್ರಿಂದ ದಿಸ್ ಈಸ್ ಯುವರ್ ಕ್ಯಾಟಯಾನಿಕ್ ಸ್ಪಿಯರ್. ಇದು ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಆದಮೇಲೆ ಬರ್ತದೆ, ಅದಕ್ಕೆ ನಾವು ಏನು ಕರೀತೇವೆ anionic sphere. ಇದನ್ನು ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಳ್ಳಿ. coordination sphere is nothing but which involving an electron donor ligands and a central metal atom or ion within a square bracket is known as coordination sphere. ಅಂದ್ರೆ ligand central metal square bracket ಅಲ್ಲಿ ಇದ್ರೆ coordination sphere ಅಂತ ಕರೀತೇವೆ. ಆಫ್ಟರ್ ದಿ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಬರೆದಿದ್ರೆ ಅದನ್ನ anionic sphere ಅಂತ ಕರೀತಾರೆ. ಬಿಫೋರ್ ದ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಬರೆದ್ರೆ ಕ್ಯಾಟಯಾನಿಕ್ ಸ್ಪಿಯರ್ ಅಂತ ಬರೀತಾರೆ. ಒಂದಿಷ್ಟು ನ್ಯೂಟ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಗಳಲ್ಲಿ ಓನ್ಲಿ ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪಿಯರ್ ಇರುತ್ತದೆ, ಅಯಾನಿಕ್ ಸ್ಪಿಯರ್ ಇರಲ್ಲ. ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಬಂದ್ರೆ ಇದು ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪಿಯರ್, ಇದು ಕ್ಯಾಟಯಾನಿಕ್ ಸ್ಪಿಯರ್. This is the today's part, friends. We keep here 3 concepts in this video: coordination entity, coordination number, and coordination sphere. Coordination entity is nothing but as the fixed number of ligands, means anions or neutral atoms is joined with central metal, is known as coordination entity. Coordination number is nothing but the total number of coordination bond between ligand and central metals. Coordination sphere nothing but a square bracket which is mentioned electron donor ligands and central metal. And these are the 3 concepts in this video. And next video, friends, we move on to the major part and different types of ligands. Ligands ಗಳನ್ನ ನಾನು ಹೇಳಬೇಕು, ಅದನ್ನ ನಾನು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು. Welcome to everyone, dear friends. Once again we move on to the concept of ligands. In the last video, we know the types of ligands based on charge and based on donor sites. In the donor sites, we have 3 concepts: is a monodentate, bidentate, and polydentate ligands. And today we have a special 2 characters. One is ambidentate ligand, another one is a chelating ligands. So what are ambidentate ligands? Keep yourselves, friends. Ambidentate ligands are monodentate ligands. I repeat, ambidentate ligands are the monodentate ligands, but they involve Ambidentate ligands are the monodentate ligands, but they involve two donor sites. Finally, they coordinate from one side. ಅರ್ಥ ಆಯ್ತು ಅಂತಂದ್ರೆ ನಿಮಗೆ ಎಂಬಿಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ಗಳು ಮೊನೋಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ ಆಗಿರುತ್ತದೆ, ಬಟ್ ಅದರಲ್ಲಿ ಎರಡು ಡೋನಾರ್ ಸೈಟ್ ಇದ್ದು ಕೊನೆಗೆ ಅದು ಒಂದು ಕಡೆಯಿಂದ ಮಾತ್ರ ಕೋಆರ್ಡಿನೇಟ್ ಆಗ್ತದೆ. ನೋಡಿ, ಎಸ್ ದೇ ಆರ್ ಮೊನೋಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್, but they involve two donor sites. Finally, they coordinated from one side. Like example, yavudu sir? Cyanide, yes, and isocyanide. NC, this is a carbon donor here and a nitrogen donor. Cyanide, isocyanide. And next, NO2 and OA. Nitro and nitrato. This is a nitro. This is a nitrato. This is a nitrato. This cyanide and isocyanide. These are the monodentates. But with two donor sites. Carbon is a donor, nitrogen is a donor. Finally, they coordinated from one side. Andre, ಎರಡು ಡೋನಾರ್ ಸೈಟ್ ಇದ್ರು ಅದು ಫೈನಲಿ ಡೊನೇಷನ್ ಮಾಡೋದು ಒಂದೇ ಕಡೆ. ಹಾಗಾಗಿ ಇದನ್ನು ಆಂಬಿಡೆಂಟೇಟ್ಗಳು ಅಂತ ಕರೀತಾರೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಈಸ್ ಅನ್ ಅರ್ತ್ ವರ್ಮ್. ಎಲ್ಲರೂ ನೋಡಿದ್ವಿ ನಾವು, ಎರಿಹುಳ ಎರಡೂ ಕಡೆ ಟ್ರಾವೆಲ್ ಮಾಡ್ತದೆ, ಎರಡೂ ಕಡೆ ಈ ಕಡೆ ಹೋಗುತ್ತೆ, ಈ ಕಡೆ ಹೋಗುತ್ತೆ. ಬಟ್ ಫೈನಲಿ ಅದು ಒಂದು ಕಡೆ ಹೋಗಕ್ಕೆ ಮಾತ್ರ ಸಾಧ್ಯ ಸರ್, ಇಲ್ಲಾಂದ್ರೆ ಅದು ನಡಿ ಕಟ್ಟಾಗಿ ಹೋಗ್ಬಿಡ್ತದೆ. ಹಾಗಾದ್ರೆ ಅರ್ತ್ ವರ್ಮ್ ತರ ಎರಡೂ ಕಡೆ ಡೋನಾರ್ ಸೈಡ್ ಇದ್ದು ಅದು ಒಂದು ಸೈಡ್ ಮಾತ್ರ ಹೋಗಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡಿದ್ರೆ ಇದನ್ನು ನಾವು ಏನಂತ ಕರಿತೇವೆ? ಎಂಬಿಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರಿತೇವೆ. ಈ ಕಾನ್ಸೆಪ್ಟ್ ಆಲ್ರೆಡಿ ಬಂದಿದೆ ಮಕ್ಕಳೇ, ಎಂಬಿಡೆಂಟೆಡ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ಸ್ in haloricane and halorines. So this is one example. Nitro and nitrato. So here nitrogen donor, oxygen donor. So similarly, SCN, SNC, thiocyanate and isothiocyanate. These are the two donor sites. Other embidentate ligands are the monodentate ligands, which are having a two donor site, but finally they coordinated from one side. One side in the other coordinate ಆಗ್ತಾ ಇದ್ರೆ ಅದನ್ನು ನಾವು ಎಂಬಿಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ಗಳು ಎಂದು ಕರೆಯುತ್ತೇವೆ. This is very important. Next one, chelating. Chelating ligands. Yes, sir. What is a chelating ligands? Keep yourself, friends. Chelating ligands at least bidentate ligands. ನೋಡಿ, chelating ligand ಆಗಬಹುದು, at least bidentate ligand ಆಗಿರಬೇಕು. At least the bidentate ligand, yes, they can bind central metal. See, central. They can bind central metal in ring-like structure. Yes, these can bind the central metal in ring-like structure. It is called chelating ligands. And yavudu sir? Very simple. I have mentioned this is the copper, which can bind with the ligand is ethylene diamine. I think all of you know this is ethylene diamine is having an nitrogen donors. Just the same NH2, NH2. This is your complex. The copper can bind an ligand. This is ethylene diamine. Neutral bidentate ligand. So this neutral bidentate ligand, they can easily bind the central metal in a ring-like structure. ಹಾಗಾದ್ರೆ ಚಿಲೇಟ್ ಆಗಬೇಕಾದ್ರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನ ಹೇಗೆ ಹಿಡಿಬೇಕು ಅಂದ್ರೆ ರಿಂಗ್ ತರ ಹಿಡಿಬೇಕು. Chelating complex are more stable, friends, because they have the at least bidentate. As gone increasing the donor sites, the complex becomes the more stabilized and stabilized, friends. ಹಾಗಾಗಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಗಳನ್ನ ಮಾಡಬೇಕಾದಾಗ ನಾವು ಆದಷ್ಟು ಡೋನಾರ್ ಸೈಟ್ ಗಳನ್ನು ಹೆಚ್ಚು ಮಾಡ್ತಾ ಹೋಗ್ತೇವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನೀವು ಹಾರ್ಡ್ನೆಸ್ ಆಫ್ ವಾಟರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದಾಗ ಇದರ್ ಮ್ಯಾಗ್ನೀಷಿಯಂ ಏನಾದರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿತ್ತು ಹಾರ್ಡ್ ವಾಟರ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಕ್ಯಾನ್ ಯೂಸ್ ಇಥಿಲೀನ್ ಡಯಾಮೈನ್, EDTA, ಇಥಿಲೀನ್ ಡಯಾಮೈನ್ ಟೆಟ್ರಾಸ್ಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಗಳನ್ನು ಯೂಸ್ ಮಾಡಿದೆ. ಬಿಕಾಸ್ ಇಟ್ಸ್ ಒನ್ ಆಫ್ ದಿ ಬೆಸ್ಟ್ ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್. ಇದರ ಕೇಳಬಹುದು ನಿಮಗೆ, ವಾಟ್ ಆರ್ ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್ಸ್? They are at least a bidentate ligand. They can bind the central metal in ring-like structure. Like example, ethylene diamine, sir, either EDTA or DMG are the best concept of ambidentate ligands, and either your chelating ligand. This is a wonderful two different concept of our syllabus. So, okay friends, next move on to the types of complex. This complex are also based on their charge as well as based on the ligand. Hagare complex ಗಳನ್ನು ಎರಡು ರೀತಿ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ತೀವಿ ಮಕ್ಕಳೇ, ಒಂದು ligand ಬೇಸ್ ಮೇಲೆ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಬೇಸ್ ಮೇಲೆ. ನಾನು ಈಗ ಎಸ್ ಇಟ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ligand ಹೇಳ್ತೇನೆ. Yes, charge ಅನ್ನು ನಾವು ಆಮೇಲೆ ನೋಡುವ. Sir, how this complex is based on ligands? The first one, homoleptic complex. Yes, what are homoleptic complex? Itangandre ಏನು? Yes, we start with example and then come to the your definition. NH3 4 times SO4 or either K4 FeCl6. Homoleptic complex are the complex the central metal is surrounded by only one type of donor site, only one kind, only one type. Correct? Yes. These complex having only one type of ligands. ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಟೈಪ್ ಲಿಗ್ಯಾಂಡ್ಗಳು ಇರಬೇಕು ನೋಡಿ. ಎಸ್, ಅಮೋನಿಯಾ ಇಸ್ ಓನ್ಲಿ ಒನ್ ಟೈಪ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್, cyanide is only one type of ligand. What are homoleptic complex? Homoleptic complex are the complex which involving a central metal which is surrounded by only one type of ligand are known as homoleptic complex. Example, CuNH3 4 times SO4 or K4 FeCN6 or K3 FeCN. You can use any type of complex comes under homoleptic. And very interesting is the second one is a heteroleptic complex. Yes. You can create the definition with an example. CO NH3 4 times, this is a Cl2. Yes, this is your complex. Here heteroleptic andrenu. So now here there are two kinds of ligands. Correct? These are the complex. Yes, these complex having more than one type of ligand. ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಟೈಪ್ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿದ್ದರೆ ಅದನ್ನು ನಾವು ಏನಂತ ಕರೀತೇವೆ? ಹೆಟರೋಲೆಪ್ಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಹೆಟರೋಲೆಪ್ಟಿಕ್ ಅಂದ್ರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ವಿಚ್ ಇನ್ವಾಲ್ವಿಂಗ್ ಮೋರ್ ದ್ಯಾನ್ ಒನ್ ಕೈಂಡ್, ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ವಿಧನಾದಂತಹ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿದ್ದರೆ heteroleptic ಅಂತ ಕರೀತೇವೆ. So many examples you can use friends. Platinum which is surrounded by NH3 4 times, this is a Cl2. So many different examples which comes under your syllabus is having more than 2 ligands. ಎರಡಕ್ಕಿಂತ ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಬೇರೆ ಬೇರೆ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿದ್ದರೆ ಹೆಟರೋ ಅಂತ ಕರೀತೀವಿ. ಒಂದೇ ಟೈಪ್ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿದ್ರೆ ಹೋಮೋ ಅಂತ ಕರೀತೀವಿ. ಒಂದೇ ನಮೂನಿ ಒಂದೇ ಟೈಪ್, ನಂಬರ್ ಅಲ್ಲ. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ನಂಬರ್ 4 ಇದ್ದು ಇದು ಒಂದೇ ತರನಾದಂತಹ ಲಿಗ್ಯಾಂಡ್. ಇಲ್ಲಿ ಎರಡು ಬೇರೆ ಬೇರೆ ಲಿಗ್ಯಾಂಡ್ಗಳು ಬಂದಿದೆ. ಎರಡು ಬೇರೆ ಬೇರೆ ಲಿಗ್ಯಾಂಡ್ಗಳು ಬಂದರೆ ಅದು ಹೆಟರೋಲೆಪ್ಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗ್ತದೆ. ಒಂದೇ ತರ ಲಿಗ್ಯಾಂಡ್ ಬಂದರೆ ಹೋಮೋಲೆಪ್ಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗ್ತದೆ. ಇದು ಎನ್ಯುವಲ್ ಎಕ್ಸಾಮಿಗೆ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವೆಶ್ಚನ್. ಗಿವ್ an example of heteroleptic complex. Give an example of homoleptic complex. What are homoleptic complex? These are the complex which involve only one kind of ligand. Heteroleptic complex are the complex which involve more than one kind of ligand. ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ತರನಾದ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಹೊಂದಿದ್ರೆ ಅದು ಹೆಟರೋ ಆಗ್ತದೆ, ಒಂದೇ ಇದ್ರೆ ಹೋಮೋ ಆಗ್ತದೆ. These are the two important definition. ನಾನು ಹೇಳಿದ್ದೆ ನಿಮಗೆ the classic types of complex based on ligand ಹೇಳ್ತಾ ಇದ್ದೇನೆ. ನಾನೀಗ ಲಿಗ್ಯಾಂಡ್ಗಳನ್ನು ಇಟ್ಟುಕೊಂಡು 2 ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗ್ತದೆ, ಹೋಮೋ ಅಂಡ್ ಹೆಟರೋ. ಇನ್ನು ಬೇಸ್ಡ್ ಆನ್ ಚಾರ್ಜ್ ಹೋದರೆ 3 ತರ ಕಾಂಪ್ಲೆಕ್ಸ್ಗಳು ಬರ್ತದೆ ಮಕ್ಕಳೇ. ಕ್ಯಾಟಯಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್, ಆನಿಯಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್, ನ್ಯೂಟ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಯಾವ್ದು ಕ್ಯಾಟಯಾನ್ ಅಂತ ಕರಿತೇವೆ, ಯಾವ್ದಕ್ಕೆ ಆನಿಯಾನ್ ಅಂತ ಕರಿತೇವೆ, ಯಾವ್ದಕ್ಕೆ ನ್ಯೂಟ್ರಲ್ ಅಂತ ಕರಿತೇವೆ, ಅದನ್ನು ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಕಲಿಯೋಣ. ಬಿಕಾಸ್ ವಿ ನೋ ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ನಾವು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ ಬಂತು ಅಂದ್ರೆ then we can know the your cationic, anionic and neutral complex. Thank you so much for the watching and please keep practicing. Welcome to everyone, dear friends. Let me move on to the next bit of the topic is coordination norms. Dear friends, today we have to know little concepts of some name of ligands and their chemical composition. Difference, we know there are three types of ligands, cationic ligands, anionic ligands and neutral ligands in the last class. The cationic, we have a very few examples. One is NO2 plus is a nitronium ion, and similarly NO is a component is a nitrogen. So many components which is comes under cationic ligands. But today we have quite familiar about these concepts because which helps for the IUPAC nomenclature of coordination compounds. Let us begin, friends. The type of anionic ligands and the corresponding names. Yes, if you use the compound is Br minus, generally we call it as X minus. X stands for halogen. This halogen is pronounced as a ligand in coordination compounds is a halo. Similarly, the component if you use Br minus is pronounced as a bromido. F minus is a fluorido, Cl minus is a chlorido, and OH, hydroxyl commonly, the OH minus is carried out hydroxido, C and cyanide is pronounced as a cyanido, oxalate C2O4 minus 2 oxalate is a oxalato, and carbonate CO3 minus 2 carbonato. These are the pronunciation of the ligands corresponding to these formulas. You keep yourself. Yes, so with the charge, you keep a Br is minus 1, F is minus 1, Cl is minus 1, OH is minus 1, cyanide is minus 1, yes, oxalate is minus 2, carbonate is also minus 2. And similarly, the acetate, CH3CO minus, pronounced as acetato, and NO2 minus is nitrato. Yes, this is a little major part of these two ligands because they are comes under ambidentate ligand. NO2 is a nitrato, N it is a nitrogen coordination, and similarly ONO it is also minus, there is a nitrato, O this is an oxygen is a coordination. Similarly thiocyanate, yes, sulfur is coordination, and NCS the nitrogen is coordination. This is the term to pronounce as acetato, nitrato, N, nitrato, O, thiocyanato, S and thiocyanato, N. These are the concept of anionic ligands. Similarly, the major part of our syllabus is neutral ligands. I'm quite familiar about the neutral ligand. I think all of you know ammonia is a Lewis base. The ammonia H3 is pronounced as amine. Water H2O is pronounced as aqua. NO, it's not no, it's NO is pronounced as a nitrosyl. CO, carbon monoxide is pronounced as a carbonyl. It's a pyridine, is as usual pyridine. This is ethylene diamine. I think all of you know the symbolical representation is EN. Yes, ethylene diamine is pronounced as ethane 1,2 diamine. These are the major part of our different ligands. You keep practicing with their charges and the donation of lone pair of electrons to the central metal. With the help of these common ligands, can easy to calculate the oxidation state of central metal, friends. And dear friends, after the nomenclature naming of the ligands, we move on to the how to calculate the oxidation state of central metal. Keep yourself seeing nothing but central metal atom or ion in a coordination complex. Let us begin, friends. We have a simple compound of our syllabus CuNH3 4 times SO4. How to calculate the oxidation state of central metal? Very simple, friends. Yes, we know the charge of the ligands and some anions or ionic spheres. This is ionic spheres. Yes, there are two types of ionic spheres. One is cationic and anion. Cation, this is a potassium and sodium. These are quite common, plus one charge. Similarly, SO4 sulfate is -2. Carbonate if comes under, this is a -2. Halogens are comes under -1. These are the charge you remember which helps to calculation of oxidation state. Yes, friends, this is a square bracket we mentioned as a coordination sphere. Apart from the square bracket we call is an ionic sphere. After coordination sphere it is anionic sphere. Very simple how to calculate. We underline this copper, as copper is nothing but X. You have to find out plus total number of ligands are 4. Ammonia is a neutral, the charge is 0. Yes, the net charge is given, so 0. The component, yes, yes, easy to know the sulfate. Sulfate is a minus 2, is equal to is a minus 2. Yes, the whole charge of the component which is easily available and our syllabus. Yes, based on this you can easily calculate the whole charge of the complex is minus 2, this is a 0. The net whole charge of the complex is becomes to the 0, that's why it's minus 2, the copper is plus 2. Obviously, the whole charge of this complex is becomes to plus 2. The net whole charge of the complex is becomes to plus 2. How to know? Copper is X, ammonia is 4 into 0, this becomes 2, sulfate is minus 2. Yes, the whole term X, automatically this becomes to 0 is equal to minus 2, X is equal to minus 2. Yes, the net charge is becomes to complete the component, the net charge of the complex is comes under to the copper plus 2. Very simply you can easy to calculate. And similarly friends, this is K3, Fe, Cn 6 times. Yes, we know the potassium. Potassium is plus 3. The component is becomes to plus 3. Yes, this is a plus 3. Iron we can find out. And cyanide is each charge is a minus. This is component is becomes to the X. They becomes to the 6 into minus 1. And this is a minus 6. Minus 6 plus 3. The charge is becomes to the plus 3. The total net charge is becomes to 0. Yes, you close ionic sphere, 6 minus 3 is becomes to the minus 3. Yes, very simple calculation of the oxidation state. This is the oxidation state of the central metal. Yes, the plus 3 is a component which is available to the net whole charge of the complex. Net whole charge of the complex number. Yes, based on this, you can easy to calculate the oxidation state of every central metal in our syllabus. If you consider another example, K4, Fe, Cn 6 times. Directly, this potassium is plus 4, cyanide is minus 6, each carries minus 1. Yes, minus 6, that comes to the 0, automatically they becomes to the plus 2. And close this ionic sphere, minus 6 plus 2, the net charge is becomes to the minus 4. This is your charge of the complex. Similarly, NiCO 4 times. It is only the coordination sphere. Keep yourself, carbonyl is a neutral ligand is 0. If it's 0, the nickel is becomes to 0. The net whole charge is becomes to the 0. This is also one type of neutral complex. Yes, if you use another one, FeCO 5 times, pentacarbonyl iron. Yes friends, carbonyl is 0, iron is 0, net charge is 0. Yes, the oxidation state of the copper is plus 2, the oxidation state of iron is plus 3, the oxidation state of iron is plus 2, here nickel 0 and iron 0. Similarly, you can easy to calculate so many complex in our syllabus based on the component. You can easy to calculate of our syllabus. Yes, I can use Na3, Fe, OX thrice. This is also one example. Yes, ox means oxalato. Yes, sodium is 3, automatically this is a plus 3. Oxalate is a bidentate, each carries minus 2. Minus 2 into 3 is becomes to minus 6. Okay, the net charge of the complex is 0. That's why minus 6 plus 3, they automatically plus 3. This is close here. Minus 3 and plus 3, this is minus 3. Can easy to calculate a kind of example. Because totally new central metal oxidation state calculate ಮಾಡಲಿಕ್ಕೆ ಬರ್ತದೆ. So ಇದನ್ನು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತಾ ಹೋಗ್ರಿ ಮಕ್ಕಳೇ. You can easy to earn 2 marks for your calculation. Your calculation ಅಲ್ಲಿ ನಾವು ಈಸಿಯಾಗಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಯಾವುದೇ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕೊಟ್ಟರೆ you can easily mention. Okay, ಬರಬಹುದಲ್ಲ? So this is the major part to the calculate the oxidation state of central metal. Okay, thank you so much dear friends, and then we move on to the complex ion and type of